In Lesson 56, we'll be discussing finite and infinite sets, membership in a set, and then talking about rearranging an equation, a linear equation, before we graph it. Part A is about finite and infinite sets. Now, a set that's usually bounded by some braces, and it's a collection of numbers. And we've talked about some specific sets of numbers, such as integers and real numbers, counting numbers, and whole numbers. A finite set would just have a collection, a specific collection of numbers, or a finite collection of numbers, like 1, 2, 3, 4, and that was it, those 4 members of that set. An infinite set, though, that's the difference here between a finite and infinite, that might have some numbers like that, and then dots on the end to say that that pattern or that group went on forever. In other words, it continued on infinitely. There was no end to that set of numbers. So that's the difference between a finite and infinite set. Now, when we're talking about membership in a set, that means, is a number part of a set or is it not part of a set? And there's a certain symbol that is used to describe if a number is a member of a set or not. So we use that symbol. It kind of looks like an E to say, yes, this number is a member of a set. Like if you had a set A, for example, there. It includes 2, 3, 4, and 5. We could say that 4 is a member of set A. So that symbol in the middle there, that means is a member of. Now, if we want to say it's not a member of a set, we could say, like 7. 7 is not in set A, so we'd say 7, and we use our member symbol with a slash through it to say it is not a member of set A. 7 is not a member of set A. Let's go ahead and do a practice problem. Look at practice problem A. I want you to represent those numbers 0, 2, 5, 4, 2, 1, and 0 as members of set S. So what you can do there is just write capital S equals and then put a brace. And you don't do numbers twice when you're representing them in a set. So we would just have 0 one time, 1, 2, just do that one time even though it's displayed twice there, 4, and 5. So that would be set S. That's just a definition. It's just a way that sets are represented. If you have a group of numbers and you want to represent them in a set notation, you don't repeat the numbers more than one time. Now look at practice problems B, C, and D. All I want you to do is tell me if those statements are true or false for that set S. So in B we have 3 is a member of set S. Well, that would be false because 3 is not in that set. So we'll just say F for false. C, 2 is a member of set S. Yes, that is true. So we'll say T for true there. And then 6, or D, 6 is not a member of set S. Well, that is true. 6 is not a member of set S. So we'd say T for true on that one. Well, the next part of this lesson deals with equations of a line and rearranging them before we graph them. In Lesson 51, you learned how to graph equations of a line on a XY coordinate system or Cartesian coordinate system, and you usually, or you always had equations where y was on one side and then equals x plus a constant of some kind, like maybe a 4. And so it was already y equals something. That's the difference in this lesson. You'll have to rearrange them to get y by itself on the left-hand side, then go ahead and do your graphing. Let's go ahead and do a practice problem. Look at practice problem E. 3x minus 2y is equal to 8. So that's an equation of a line. It's a polynomial equation with 2 terms in it, or 2 variables, both first-degree variables. So we know that that represents an equation of a line. We just need to get it in the form y equals something times x plus a constant. So let's go ahead and start trying to get y by itself. We would do that by adding a negative 3x to both sides. That cancels the 3x's on the left, and we have negative 2y is equal to, I'll put the negative 3x first, because usually that's how it is when we work with an equation of a line. That's just something, a standard way of doing it. We put the x term first and the constant term second. Now, let's go ahead and divide everything by negative 2. So we do negative 2 there, and everything on the right-hand side needs to be divided by negative 2. Cancel the negative 2's on the left. On the right, we end up with y is equal to a positive 3/2 times x plus 4, because negative 8 over negative 2 is positive 4. Now we're ready to go ahead and figure out our xy points. So let's go ahead and do that. Make an xy table. And xy points, that's not really a good description. Xy pairs, or ordered pairs. Choose some convenient values for x. I'm going to use -2, 0, and positive 2. The reason I use the 2's is because I have that fraction there, that 3/2, and if I use a 2, it'll cancel the 2 and 3/2, and I'll end up with a whole number, and that'll be easier to work with. Remember on these that there's an infinite number of x values you can use. You don't have to use 3, you can use 5 or 7 or however many you want to plot on there to make a nice line on your graph. So now I've got negative 2. Let's figure out what the corresponding value for y would be. 3/2 times negative 2, that would be a negative 3, plus 4 is equal to 1. So when x is negative 2, y is 1. When x is 0, y is 4. And then when x is 2, I'd have 3/2 times 2, which would just be 3, plus 4 is 7. Now I need to go ahead and make a Cartesian coordinate system. And I'll have to go ahead and draw that so that it will include those points on it, and I can draw a nice line using those points. So you should be making a Cartesian coordinate system too. Don't just be watching what I'm doing. Okay, so now we can go ahead and plot those points. It's helpful to use a different color pen or pencil when you plot your points, just so the line will show up better. And so for the first pair we have -2, 1. That means you move to the left 2 and up 1. Then you have 0, 4, so you move to the left or right none and just go straight up 4. And then the next one is 2, 7. To the right 2 and up 7. So that's the third point. You can see the linear pattern that those are following. So you just draw a line right on through those. And there's your graphed line representing that equation. So when you're solving for an equation of a line and trying to graph that equation, you always want to rearrange it first if you need to. If y is already by itself on one side, you don't need to rearrange. But if it's not, go ahead and rearrange, set it up equal to y, then go ahead and find out what your xy pairs are. Just pick 3 xy pairs, plot those, and make your graph. Okay, well that's all for lesson 56.